Hey guys, it's Emil here. Today we're going to do the electronic structure portion of our collinear calculation. So, if we head over here to our DFT+U spin orbit coupled, all right, we finished step one, initial collinear SCF calculation. Now we're doing, relaxation. Now we're doing the SCF calculation. And this one, all you really got to look at it as you're doing a band structure calculation, and that's going to be pretty simple. Right, so we head over to our Incar, and again, this is all provided on my website. You can probably find it in the creating files portion for the Incar template. So all I do here is I'm going to comment out the optimization portion and uncomment the density of states band structure portion. And again, we're going to leave, we don't need this iCharge portion. This is for your band structure. So now that we've got that out of the way, let's look at our job. Collinear, we'll just name it density of states, because that's what we'll get out of this. Let's double check the Incar's all right. Yes, I spin is 2. And again, the DFT+U tag is going to stay on during the entirety of this. And that should be it. So I'll be back once this is completed, and we will analyze the density of states for curiosity reasons and go through it. Oh, I guess it'll be done pretty shortly. So as you can see here, our electronic structure is all done. Density of states is all done. And what I like to do is I like to use PyProcar to look at the density of states. Actually, we could use my own software, my own website. Let's see. So for analysis, all I need is the DOSCAR. We will put that to here. And the POSCAR. Then I will open that up. Again, you could find this in a tutorial or my own website, or the ONIC Lab website. It should be all there. I'll actually rename that. Wait, what is this? Yeah, I'm going to rename this to Collinear. I will download this. Is it downloading? Maybe not. Okay, there we go. I think I'm getting trolled. So that's all downloaded. We will zip this as well, compress it on Mac. We'll go over upload file with POSCAR and DOSCAR. Oh, it's on my desktop, that's why. And there we go. So I think since the last time I've showed this, I've updated it a considerable amount, so you could actually move the order of the legend. You can move RH rhodium up. I'm just trying to figure out the color scheme here. Do that to 0.1, get rid of the 0. Okay, so uranium will be blue, germanium will be green, and we'll make rhodium this orange. So that should fit the overall color conventions that I do. Yeah, it looks about right. Roughly. Okay, so now you could pretty much view your spin up and spin down states as well for whatever you'd like to look at. However, it doesn't take into account, there is no F states for rhodium just yet. Maybe in a future update I'll go through and edit that. Same with the germanium, so that'll also be just p orbitals, right? Yeah, so we'll save the plot as is. And I guess if you also want to look at your magnetic properties, all you do is head over to the Outcar, go over to magnetization, and you could see that you have a moment of 2.25 for your respective uranium atoms. Yeah, and that should pretty much be it. So in the next video, I'll go over the, actually doing the collinear portion, or excuse me, the non-collinear portion, and continue with this there. So thanks for watching. Again, any questions, comments, concerns, queries, feel free to email me or head over to the comment section. Look forward to seeing you soon.